Good afternoon, Algebra 2 class, and welcome to 14.5. Nearing the end of the year, and last little bit of work we want to do before we're going to have a final. It's not going to be like a normal final, but you'll see. We just want to do things a little bit different this year. So, as we look at this is the types of conic sections that we have: the circle, the ellipse, and the parabola. And so, as you know, circle, ellipse, parabola, and there are some definitions when it comes time for you to take your test. Might be handy to have these available so you know what to expect and what we'll be looking for. All right. We also have two intersecting lines like this, or just the line, the point, and the hyperbola are all different conical sections. And these definitions are just on here, so I put them in here in the notes so people know this is what's going to be on the test, and be ready. You will see this. So I just want you to be very, very ready so you know what's coming. Okay? All right. Here you go. Here's the conical sections that we have. You can see if you have two cones stacked on top of each other, you can see the parabola, the circle, the ellipse, and the hyperbola. Here's different parts of the cone. You can see there's the element of the cone. The vertex is the 2 points at which the cones come together, and the axis is this. Oops, excuse me, that's not what I wanted. This line right down here is the axis of the cone, and the cone itself is the nape. And so that just so if you have one cone, it's the nape. All right. So if you were to look at these, parabola is the intersection of a right circular conical surface in a plane that is parallel to the element. If the element is the edge of the plane of the cone, then a parabola comes down parallel to it. A circle is perpendicular to the axis, and you can see right there. I've always said it's like if you take a cone and you like slice it through, that's what you would have left would be right here would be the circle that's left. There's the hyperbola, which passes through both cones. And there's the ellipse, which is very, very similar to the circle, except for you can see here it's not parallel to not perpendicular to the axis, but it still passes through the nape of the cone. All right. Other conical sections. So if I were to sketch a set of cones for you, let me get this in black. You could have the line or the point. So if you took a cross section right there at the vertex, it would be a point. If you took a cross section that is the element, it would be a line. And the equation for a line, you could have a conical section equation for the line would be y equals mx plus b. All right, and we're familiar with those types of these types of things, conical sections. All right. So now here's a couple of types of questions you'll see on tonight's homework after you have some questions about the different types of conical sections. What type of conical section is it? And graph it. So if we look back at our graphing forms, which one looks like this? X minus h squared over a squared plus y minus k squared over b squared equals 1. Well, that ought to tell you which one we're looking at, but maybe you're having troubles figuring out which one is which. So we could figure that out here. Let's go to the center. We've got 1 -3. And then in the horizontal direction, we go 6 over, and 3, 4, 5, 6 over, and we go 3 up, 1, 2, 3, and 3 down. So, and then it's positive in between, so I graph it like that. And I would say that that's an ellipse. And that is in ellipse graphing form. How about this one? This one's a little bit more difficult for me to tell, especially just starting out and looking at it. So let's just begin working on it, and let's see what we got. First thing I do is I'm going to separate all the x's and y's. So I've got 4x squared plus 6y, excuse that, 6y squared minus 36y equals -30. We'll move that 30 to the other side, okay? All right, now what I'd like to do is I would like to factor out 4, then we got x squared, my coefficients, plus 6 times y squared minus 6y equals -30. Now I'd like to, right here, this one doesn't have anything that can complete the square, but on the second one I'd like to complete the square. So we got 4x squared plus 6 times y squared minus 6y. Now if I took b divided by 2, I get -3. And I star the -3, and then I square it to get 9. So if I have 9 there, and I want to add that to the other side, I'm going to actually add 54. Do you know why I added 54 and not 9? Well, the reason I added 54 is that because 6 times 9 gives me the 54. Because remember, you have to multiply that 6 to each term. Okay? So now when I put it into a little bit closer to graphing form, 4x squared plus 6 times y minus 3, that was a CTS. Remember, if I took b over 2, star it, and square it, my b over 2 value is -6 over 2 squared, which gives me -3 squared, which was 9, and star it. So that's how I got the -3 here, equals 24. All right, so then it comes up to dividing by 1, and we get x squared over 6. Now, excuse me, let me explain that a little bit better, how I got that value. What I was doing, dividing by 24 here, dividing by 24 here, and dividing by 24 here. The purpose of that was so that I could make the right-hand side equal 1. So I can reduce this to 6, and I can reduce this to 4. And if this is the equation that I've got, I'm going to say that this is ellipse at 0, 3, because it's an ellipse equation just like the last one. Ellipse. It asks me up top which type it is. And 0, 3 is my vertex. It doesn't say anything about finding, I don't have to find the focal points or anything like that in this particular lesson. So in the x direction, I go over square root of 6. And I got a calculator here someplace. The square root of 6 is approximately 2.45. Square root of 6, approximately 2.45, so 2.5. So we'll go over 2.5 and 2.5 and 2.5 up. 2, or not 2.5, just 2 up and 2 down. There's my ellipse. All right, let's look at another one. Oh boy, another one where it's not in graphing form. So I got to go through the same process to get it there. So I'm going to separate the x and y's and put the left-hand side. Also, something I want to pay attention to in a problem like this is this thing right there, that greater than sign. So let's not forget about that. So we're going to get the x's together. 9x squared minus 18x plus 25y squared plus 200y greater than negative 194. Just so happens I got 3 ellipses, it looks like. I think it's going to be. So I got 9 times x squared minus 2x plus 25 times y squared plus 8y is greater than negative 194. Now, the next step I want to do in graphing form is perform a CTS. So when I do that, I get 9 times x squared minus 2x, and negative 2 divided by 2 is negative 1. Negative 1 squared is 1. And again, I was using, for that step, I was using b squared, b over 2 star it and square it. And that's what I'm using to get that 1. That's 25 times y squared plus 8y. 8 divided by 2 is 4. 4 squared is 16. Okay? That is greater than negative 194, which I got from right there. But then I'm going to color code this for you. I'm going to add 9, because if I add 1 over here, 1 times 9 is 9. And then I'm going to add whatever 25 times 16 is. I'm guessing about 400. 400, you might say, how'd you get 400? 16 times 25 is 400. So now let's simplify that a little bit. 9 times x minus 1, remember, perform the CTS, plus 25 times y plus 4, again the CTS, is greater than, and now we'll take our 400 plus 9 minus 194 gives us 215. Really, 215. I didn't think it was going to come out. I was thinking 225. Okay, anyways, that's ugly. Probably for upcoming years I'll change this just a little bit, because if I had made that negative 184, it would have made it would have been a lot easier problem to do. So now we're going to divide everything by 215. So we're going to negative x minus 1 squared over 215 plus 25 times y plus 4 squared over 215 is greater than or equal to 1. So now if I reduce those to get a squared and b squared on the bottom, I'm going to get x, this is where it gets ugly. That's why I'm saying I could make this easier by myself by making that bottom number 225. So if we had 215 divided by 9, we get 23.8. And for the other one, 215 divided by 25 is 8.6, so it would be y plus 4 squared over 8.6 greater than 1. Again, I was trying to see if just a moment ago if I had made a mistake, but it doesn't look like it had. Hopefully, again, if this had been 225, 225 is 9 times 25. So if that was 225, this whole thing would have been easier, but it wasn't, so we'll go with that, okay? So our center is at 1, -4, and the square root of 23.8 is 4.8, so 23, the square root of 23.8 is approximately 4.9. So that means in the vertical direction, I go up 1, 2, 3, 4, 5-ish, and down about 1, 2, 3, 4. Let's pretend that just goes down to 4.9-ish between here and here. Okay, and then the square root of 8.6 is 2.93, so about 3. So 8.6 is square root is approximately 2.9. So we're going about 3 over, 1, 2, just below 3, and 1, 2, just below 3. So there's my ellipse. I'm going to pretend that it goes down to where it's going to, and it looks just like that. All right, there's your homework. Let me get the book out here so I can reduce your homework for you. Page 642 to 643. I'm going to change it. It was 1 to 12, 15 to 18, and 25, 26, 30, and 31. Let me make it 1 to 6, 15 and 16, and 25. Okay, let's do that. There you go. That's what you can do for this year. Thank you very much for your time. Have a good day.